Hello everyone, I'm Amaz Iqbal. Today we will delve into electrical drawing and explore the fundamental of electrical system found in the UK households. It's essential to grasp these basics before diving into the technical aspects of electrical system. Remember, if you encounter any issues with your domestic wiring system, it's best to hire a qualified and experienced electrician. Avoid attempting any DIY fixes unless you are familiar with the proper electrical safe isolation procedure. Let's begin. Hi everyone, let's talk about what we normally find in our domestic properties. This is um, concentric cable. This is a main supply cable that we have quite normally in the new build. This is what we normally find in the new build houses. In old house property, you're probably going to find a different type of cutout. This is a supplier cutout, and this is a supplied fuse to disconnect the supply from your domestic side of your side, so they can pull this fuse out to disconnect the supply. If they want to disconnect the supply from to your house. So this is where they're going to pull this fuse out. This is you will find this fuse in a different size. So don't go by the label. Sometimes you find a label of 60 amp. Yeah, sorry, 60 amp. You probably find 80 amp and sometimes 100 amp label there, but might be a 60 amp fuse in there. But that could be different. So it depends. So yeah, this is incoming man supply. This is normally not normally because of this is PME system. It's a new system. You will find this cable there. It looked like armored cable, steel wire armored cable, but it isn't. It is a concentric cable. It has got a middle part, which is the line conductor. Then it's got insulation on top of it. Then on top of insulation, there's going to be a layer of the cable, like we find on top of armor cable. So these the cables going to be a combined um, neutral and earth cable. So this is what it's called PME or TNCS system. So basically, this is the um, man supply cables. When it comes to the cutout, the line cable, the man live cable, line cable, we call it. That's gonna go here, and the other cable, neutral and neutral combined earth, that will go there. Okay, so this is gonna be, as I said, this is whole this is, this system is called what we got here. It's called supply cutout, and this is supply cutout fuse, as I already mentioned. the to disconnect the supply from your meter. So, for example, if you need to upgrade this meter, the supplier, your energy supplier, they need to upgrade this meter. They need to isolate the supply, and to isolate the supply, they can take this fuse out and then they can upgrade the meter, or anything needs to be done on this side. Obviously, if they need to be disconnected supply, this is isolator, this is the fuse, they need to pull it out. You will find a seal on top and bottom, but yeah, that's the seal for you know um, that's from your DNO, distributor network operator. That's belong to them, and as electrician, we're not allowed to pull this fuse out unless your DNO local. It depends where you live. Where I live in West Midland areas, National Grid, they wouldn't be happy if we're going to be pulling the fuse out to work on this site. So we have to notify them, and they got their dedicated team. They come on site, obviously. Then you need to book appointment with them. It depends whether you're going to give them a week notice, 2 week notice, or that could be something need to be done urgently. But it is a chargeable job as far as I know. So yeah, even just to pull the fuse out, they are going to charge you. Yeah, so this is a supply meter, as I said. So they're going to be a line and neutral cable. So two cable meter tails are going to go from line from here to the meter. Neutral is going to come out from here. That's going to connect to your meter as well. From meter, the cable meter tails, they're going to be connecting to your consumer board. This is the consumer board, your distribution board. So you got a line cable that's going to connect to this side, right hand side, where this bus bar is connected to the bottom of all the main switch and the SPD and RCBOs. And left side you will have your neutral cable that's going to be connected up here, and the bottom part, the neutral, will come out and connect to your neutral bar. So this is the neutral terminal bar. That's where your all RCBOs neutral tail is going to be connected there. This is a double pole man switch. Yeah, it is basically if you want to turn your line and neutral part together, you just need to flip it up and down. It depends. Normally, you got writing there tell you on and off, so you can turn it off. Yeah, to disconnect the supply from this side of the consumer unit, but it doesn't mean that's not going to be alive here. These up there, you can see these two terminal. The cable is, obviously that's still a live part. So anything at bottom there, you need to check, make sure you carry out safe isolation procedure before carrying out any work. This is a type 2 SPD. So the type 2 SPD is something it is mandatory now. There used to be a risk assessment. We used to, as an electrician, would be asked to use a risk assessment to install a SPD surge protection device, but that's not something it's not something we need to decide on, whether we need to install or not. It's mandatory. So all domestic property, they need to have type 2 surge protection device. What this surge protection device does basically, in the UK, we got single phase supply is up to 230 volts. If there's electric surge, that could be a 300 volt or 400 volts going to go through your um, you know circuit, and they could cause damage to your appliances such as your fridge, freezer, television. It depends what you have on the other end of your circuit. So they are made to handle up to 240 volt. But if there is electric surge, there's going to be a lot of voltage going through to your circuit. And what this does, this SPD, this SPD will um, trigger and make sure if there's any electrical surge, that will protect your appliance. It will, if there is a surge, obviously there's going to be you will find a label. If it's a red, you need to replace it. So there's going to be a label there if it's a red. So that means you need to make sure you need to replace it as soon as you can, because it's not going to be it's done the job, but it's no good for a future user. You need to replace this to make sure you in the future if there is electric surge, so you got a new SPD installed there. Okay, next, these all 8, you can see these RCBOs, so I've labeled them RCBOs, but it depends now. They could be MCBs, RCBOs, but if these are MCB, you will find RCD in between somewhere there. But in this scenario, I've just got RCBOs because I think we are, getting toward RCBO and segregation. So if you got a RCD there, so you do find some houses still use RCDs, but if there is RCD, it works like a mini man switch with the additional protection. So if there is a problem, any fault protection there, your RCD trigger and half of the board, your half of the board stop working, and then this, one of the RCD will trigger. But if you have got a RCBO, then you don't have to worry about that, because these RCBOs got built-in function. They do, give you protection about short circuit and fault protection. If there is a problem with this circuit, so all these going to be working, and that's going to go off. So this is where the RCBO is something we need to be looking into it. But yeah, things are changing. So I now these days, obviously, this is a multi-story. If there is hold people home. You know, there could be some of the HMO houses. If you're going to be working there in electrical system, if you're going to be doing electrical installation as an electrician, or you're going to be hiring as a landlord, you're going to be hiring an electrician, you need to make sure, these are CBOs, they're not going to be good there because according to new regulation, we need to have R4 detection device, AFDD. So with this one, you get short circuit additional protection, but with the AFDD, you're going to have R4 detection device as well. If there is arc, you know, sometimes you do find your shower pull cord it's been arcing and you have the cables burned there. That could be anywhere. It doesn't have to be shower. It could be any immersion heater, other appliances such as any heater. So if they're gonna overheat, they're gonna be arc, and if they are next to combustible material, that could cause problem. This is something dangerous. It could be a fire hazard. So this is why. Um, these been replaced with arc fall detection device. But in a domestic property, we still use them. They're still fine. Later on we're probably going to be yeah be um, probably going to be installing R fall detection device. But right now uh, we can still install these, but we still need to carry a risk assessment if we find some, where we think there is a fire hazard. So we're probably going to be installing one or two R4 detection devices. Um, it could be half of the RCBOs installed there and half of the R4 detection devices, but it depends. Okay, let's talk about what this is at the bottom there. This is the bus bar. This is obviously the line cable, the main line cable coming to this side that link all these RCPOs and SPDs. So the bus bar is basically it connect all your circuit to your line side. When I say line, that's a live cable. So this is the brown cable. I'm not talking about neutral. So if I say live, so some people probably gonna think, okay, well I'm saying line. I should say live, but neutral is live as well. Um, you know, we as electrician we call live both neutral and line both we call them live. So this is why I'm to identify to give you a bit more explanation. So our brown cable, the one that's going to come from your meter to the consumer unit man switch, that's the line cable that's going to be connected to your man switch on this end, and this is the bus bar that's going to link all your RCBR that I explained already explained. Okay, what this is the DIN rail. So to fix all these RCBO, SPD, and man switch, this is what you're going to find. You can hang them on there, so they're going to be fixed. There will be a clip at the bottom there in each RCBO, SPD, and a man switch. And SPD sometimes has got spring-type flip, which is going to be fixed to the dim rail. Yeah, but it's not something you can't fit to this DIN rail. They're all going to be fitted to this DIN rail. So one thing I just wanted to mention, so some of you are probably going to be thinking, okay, I've got a man switch there and SPD, but there should be MCB that should link to the SPD, but it depends which make you're going to be using. Some of the consumer unit, they have got a MCB there, probably 32M, 40M MCB that you can connect to your SPD, and SPD is not going to be directly connected to a bus bar that could be on this end. But yeah, some of them they will have this side of the man switch, and then you can connect. There's going to be another cable or link something to connecting to the SPD. But yeah, I've worked on a different consumer unit, but this is you're probably aware about Niglan consumer unit. They do have a terminal for your neutral and earth on top there. So which is earth is going to be connected to the earthing terminal and neutral is going to be connected to neutral terminal. But the bottom you can still fix this SPD on top of the bus bar. So as long as they are the terminal at the bottom terminal, they're the same. If you can link them, that's fine. So if the bus bar can go easily in there, make sure these terminal, when you screw them, you need to make sure they need to be within there should be a small clamp there, so they shouldn't be, left uh, loose inside the RCBO. So just to make sure, you need to double check they all firmly um, connected to your RCBO, SPDs, and your man switch. If they are loose, then later on, probably down the line somewhere where you're going to be using this, where customers going to be using electrical supply, they're going to be probably going to have their heating, um, could be your shower, a cooker, any circuits that could be missing. This bus bar is missing, the link is missing at the bottom there, is not firmly connected there, and that if it's not inside the terminal, that could cause a problem, that could start arcing, and that arc could lead to the rest of the consumer board to catch a fire. And sometimes you do find up there as well. So a lot of people think they are, because the meter tails are coming to your man switch, so you will see this side, the meter tails got stuck there because this side is the burnt. A lot of people think it's because of the overload, but I strongly believe it's not because of the overload. If there would have been overload, these breakers there and they should trip. Um, you know, but if they are, it depends. If you how big your board is, but yeah, most of the time, it is going to be a loose connection up there. So make sure whenever you call electrician, you need to make sure they do understand what they're doing, and they're not just a DIY man to working on your consumer unit, working with the drill. Sometimes I find them with impact driver, and if they're going to be screwing these up with the meter tail with the impact driver or electric screwdriver, and they're probably going to be there might be a problem where there won't be any thread left, and this screw is going to be loose. If this screw is loose, obviously then it could cause a problem later on, and it could start arcing, and your consumer unit can catch fire. And the second reason I can see there, sometimes as an electrician, we always make sure, these the meter tail, they need the copper part on top shouldn't be exposed up there. There has to be a full in there, but that doesn't mean this screw need to be on top of the insulation. If it is on top of the insulation part, that's going to be another issue. So, because you are basically the copper is below this screw, and insulation part, you are working, you screwed your meter tail with the on top of the insulation, so the copper is under there, that's going to be a loose, that could cause problem, overheating or arcing, that could lose connection, that could cause a problem, and it can catch a fire. The third reason that could be, when you bend the cable, just to make sure the cables, the copper probably going to be a same size and balance. But when you bend them, there you will find probably 45-degree coppers and the one angle. You probably need to trim them just to make sure they are, they are level. They're not the 40s. It's not like you slice them from the side. They should be a level. So if that's the case, that could be another reason, because you screw them up. Half of the copper is inside the screw, and half of the copper probably going to be on the side. That's again loose connection that could cause a problem. So as I said, there's three things. One, don't use a drill or your impact driver to screw this up, to tighten this screw. And the second reason I said, don't screw this one on top of your meter tail insulation. Third one, just to make sure when you bend the cable, make sure you make them level, and before you put in these terminal and screw them up. And this side, you need to make sure these all bus bar they are inside the right terminal. They shouldn't be. You will find a small metal terminal there. This bus bar is supposed to go in there. They shouldn't be behind the screw. Obviously, if you're going to be pushing them, they might be in contact of the plastic of these RCBOs, and that could again cause a arcing, and arcing could lead to the fire. So this is where we have got a metal consumer unit. Again, if it's a metal consumer unit, that doesn't mean now we can just leave it. There could be sometime you will find a big hole there, and this consumer unit is fixed on right on top of the combustible material, and that could be something your plasterboard, and some electrician they tend to cut the plasterboard and to fix the board inside, but we need to make sure there's going to be insulation in there. If there is a slight arcing there, right next to the cable coming out, sorry, coming into the consumer unit from these couple of knockout you will find in your consumer unit, then if they're not sealed properly, of this right on top of the combustible material, then obviously you need to take into consideration how you're going to seal them. If there is a insulation there, if there's a arcing there, that could lead to the your insulation material inside that could catch fire, and that could lead to your whole house in the fire. Okay. I think I've discussed enough. Let's talk about now. This is earth terminal. So basically, when you install any circuit, that could be your lighting circuit, your cooker circuit, your shower circuit, your immersion circuit, your boiler circuit, your socket, ring man, whatever. So you will have twin and earth cable. So the two cable, line and neutral, they're going to come inside your RCBOs here, and the earth cable is going to be connected to earthing terminal. So these RCBO, they do have a tails as well, neutral tail. They need to be linked to the neutral side. So they're going to be, this is neutral terminal. So their tail is going to be linked to these accordingly. So if this one is the very first circuit, that could be this one. They're all numbers. So it's a good practice just to put them in the right number. If you're going to be working from this side, if it's the first number there, so this one's going to be your earth cable is going to go there, first one, second one there, third one there. So just to give you idea, if somebody's coming later on, they know if they're going to be working on this system, they know they are done properly according to the numbering. Okay. This is normally I've been working there. I just made draw this double gang socket. So this is the socket circuit. Sorry, the socket that's going to be linked to one of your RCBO there. So that means you will have a twin and earth cable. That could be 2.5 cable feeding to your socket if it's a radial. Again, if it's the ring, then again it's going to be 2.5 cable, but that's going to be a ring. The cable coming out of from the socket and linked to all sockets and going back to the same RCBOs. And you will have, instead of having one cable in there, you will find two neutral and two line cable and two earth cable if it's a ring. But if it's a radial, you will find one cable there. Then again, you need to make sure it can't be always 32 amp breaker there. Depending on the length of the cable, if it's a radial circuit, you might find a 20 amp breaker there. If it's a 20 amp, sorry, RCBOs, I should say RCBO because we're working on RCBOs. You will find 20 amp or 16 amp RCBO, depending on the cable length, installation method, grouping factor, ambient temperature, and there's a lot involved, so it's not that simple. You will have 20 amp, you might have to reduce to 16 amp sometime if your cable is too long, or if it is installation methods, different installation methods being used, or if it's going to go through the installation. So you have to consider all these factors. So there is the calculations on site and the building, sorry, the BS7671 regs books. You will find all this, how to make sure when you install your socket and lighting circuit, how to do the calculation, how to make sure your cable is the right size and appropriate, and it meet the design grant requirement. Okay. Similarly applies to your cooker circuit. In domestic property, you will find one of these isolator with the socket plug. You can put a plug there and it's a double pole isolator. So you will find the cooker circuit in your if you got electric cooker in your kitchen. So this is something you're probably going to be seeing there. Is again, it's the same thing. We need to look into it: cable length, grouping factor, installation method. So these a few things we need to look into before installing the cooker circuit. Is all in design current are probably going to be yeah, when we do the design current video in the future, I will explain further there, how to make sure we got the right size cable for the right appliances. Okay, yeah, so as I said, this is a cooker isolated with the socket. So this is basically you will find on top of your worktop, yeah, where you can plug any appliance, and at the same time there will be cooker connection somewhere under your worktop with your cooker is behind. It could be inside of the cooker or behind the cooker. So your cooker is going to be connected to the connection point there. So yeah, and this is I've just made just a light switch. This is a you're probably going to find this switch there. So that could be a double gang, triple gang, two-way, single switch at two-way, three-gang, two-gang. These days we can, well, grid switch always been it's always been in the market where we can get the grid switch as well, such as we can have instead of having three, four, we can have four, five switches. Okay, but then again, design current, we gotta make sure they are going to be able to handle the current, and if there is a these days we get LED lights, and if there is LED lights, so that might be okay. Depend how much load's going to be on your circuit. If you got a 1 mil or 1.5 mil cable, so it's always best to segregate. If you give you segregation, such as if you got a lighting, you don't want a one breaker to trip and your upstairs and downstairs lighting goes off at the same time. So you need to have upstairs separate lighting, downstairs separate, and I would go if you done if there is extension, kitchen extension. I would recommend to have another circuit downstairs for your lighting circuit. And if you have outdoor lighting, so then you make sure you have a separate independent circuit outdoor. A lot of time you will find a moisture in outside your lighting, or somebody damage your light, anything happen to light, water is going to get into your light and you will have a problem if it's linked to internal indoor lighting circuits. When there's a problem outside, if we could cause a problem inside as well. If it's lighting circuit, that's going to trip, and that will be inside and outside both. Your electric is going to go off. So ideally, you need to have a separate outdoor circuit. It depends how you want to do it. But um, if I'm going to be installing a few lights outdoor, a few lights, garden light, porch lights, it depends. Then I will definitely consider separate lighting circuit. Okay, you're probably going to find one of these RCBs feeding to your smoke and heat detector. Yeah, but sometimes you can link it to your lighting circuit as well, because a lot of people, when they say your smoke detector, they stop making noise. It depends with the passage of time. You see your batteries inside the smoke detector, if that's going to go off, if it's not charged, or if it's not suitable for continuous use, that could cause a problem for your smoke detector to trigger, and they will make noise. And a lot of people they don't have a clue as a customer. They just try to tamper with the smoke detector, heat detector. If they can't open it, they're probably gonna think, okay, we might as well switch this RCBO off, but that doesn't solve the problem. Uh, you know, if there is your smoke detector, heat detector, if they are making noise, you need to make sure if you're in your own house, you need to call the electrician, or if you are a tenant, just speak to your landlord, and they can call the electrician and come and have a look, and there might be battery in there that's gone. But these days, the new battery, the lithium battery, they give you 10 years, and you can't just replace the battery. You have to replace the old smoke detector. Okay, we'll discuss about this in a future video. But yeah, as I said, this is a light switch. Now, this is where we have color water supply. That's going to be linked to your board as well. If you got a terminal, that's going to be linked to your. This is a main bonding conductor, so that's your incoming water supply. And this side, apologies if you are a gas safe man, Kogi register, or anyone who works on the plumbing side. I've just made this picture. It probably doesn't look like um, your gas meter, but this isn't. That doesn't mean this is something. I'm an expert on this. This is just to give you a bit of information about bonding. So this is why I've got this meter there. So that's going to be again gas meter if it's a metallic pipe or you know your lead pipe. If they're not plastic, then they're going to be linked to your I think terminal here, or sometime you find there next to there. Okay, let's move into next slide. Okay, here we go. Okay, as I've already explained, this is a concentric cable. This is a main supply cable, and don't be mistaken with your armored cable. It isn't armored cable. This is a concentric cable. It's different to armored cable. So then we got these meter tails. So we got line cable. That's obviously this is a main fuse that to disconnect this cable, this line side, we need to pull this fuse out. When I say we, that doesn't mean as the electrician we can pull it out. This belongs to the network distributor, so they obviously they're going to be coming out to pull this fuse out if they're happy for you to work on this system, and they're happy for you to pull out. But make sure they are on board. If you're going to be working on this side of the system, you don't want to put yourself in a trouble and get a lot of fine. Yeah, they're going to be sealed up there and the bottom there, so they're going to come and cut it and pull the fuse out if you need to work on this side. No, this is something I've got it. Ideally you need to have this double poles isolator there if you need to work on this side. Um, but most of the time we do find meter tails coming out of the meter and feeding to the consumer side directly. So line this side, neutral this side, as I mentioned. So you won't find anything in between there. But yeah, but sometimes you can ask the network distributor, such as National Grid, they can install it for you. But this is going to be again chargeable job. It depends how much they're going to charge you. Don't ask me, they got different rates. It depends what time you're going to ring them, how many days notice you're going to give them. So, but yeah, that they'll come out as they do it. Sometime your energy supplier, that could be, they can help, they can sort it out for you. They can install it for you. But yeah, they're two different entities. Don't I think your network distribution, DNO, National Grid, they are they're the different to your energy supplier. That could be British Gas, that could be anyone, Eon. Depends who you got, who you get bill from your electric energy supplier. Okay, they obviously they're the different one to your DNO. Okay, the DNO is the National Grid, and energy supply could be anyone. And national, when I say National Grid, it doesn't mean the National Grid is going to be all over the country. So I mean where we live in the West Midland, this is National Grid normally. That belonged to them. This network used to be Western Power, but now they called National Grid. Yeah, okay. These meter tails, if we find this double pole isolator, it's the same thing what we got here in consumer unit. We just got them in enclosure. So these meter tails, instead of going directly to the main switch, they will go through this double pole isolator. So you will find a line in neutral there, as I said previously. So this is incoming side, that's going to be a seal somewhere here, and then these meter tails going to feed to your man switch consumer unit. So then this is the part where you can take this off, and if you're going to be replacing your consumer unit, make sure it's off position, and ideally pull these meter tail out if you're going to be working on this side, just in case, by mistake, if you turn it on, obviously then you could be putting yourself in a risk. So yeah, you got access, turn it off, unscrew them, pull these meter tail out, then you can replace the consumer unit. Okay, yeah, these meter tails, as I said previously, the line one is going to be connected to the line side of this man switch, and neutral is going to be connected there. The new one cable will link to this neutral bar, and this is already linked to your RCBOs. Okay, then you will find a third cable, which is, because this is PME system, TNCS system, so there's going to be a man earth cable that's going to link to your earthing terminal there. Okay, so this is the man cable. Then you sometimes you do find a earth terminal there where you can link your all earth, not if not all, some of them here, your earth terminal, but sometimes you don't find there, you will find them in your consumer unit up there, and your bonding, like such as your water supply, man protective bonding conductor, that's going to be linked to this earth terminal, and same with your gas meter, that's going to be linked to your earthing terminal as well. Okay, so the next circuit we will link to your RCBO, that's going to be a cooker circuit. Yeah, your cooker circuit. This could be a 10 mil cable, 4 mil cable, depends. 6 mil cable. So when I say 6 mil, it's a twin and earth cable. So don't just take your measuring tape or something to just start, you know, measuring this cable with your measuring tape. This is not about insulation material on top of the cable. When we say 2.5, 6 mil, 10 mil, that's cross-sectional area of the cable. That's the wire inside this insulation material. That's what we need to. This is what we mean, when we say it's a 6 mil or 2.5, whatever the size we say. So it's not insulation part of this cable. So yeah. Okay, this is a 2.5 cable. I made it slightly smaller than the 6 mil cable, so that's going to link to our socket circuit, radial circuit. And similarly, we got 1 mil cable connected to our lighting circuit. Right. Okay, now, as I've already discussed, these are the meter tails. Line and neutral, line and neutral, and meter tails we normally find 25 mil. Sometimes you do have a 16 mil. It depends if this fuse is ATM, that could be or 60 amp. Then you might have these 16 mil cable, but most of the time you will find 25 mil cable. But these meter and your supplier cutout, they are going to be close to each other. So similarly, we need to have a consumer unit. These meter tails, they should be within a 2 meter range ideally, and not more than a 3 meter. But if they are more than 3 meter, then we have to think about installation methods, how we can install them, how we're going to protect this meter tail, because anything goes wrong on this side, you gotta have a fault protection. These RCBO will trigger and they will protect you. But if anything goes wrong here, if you drill it, if they're buried inside the wall, if you're gonna drill it, you got no protection there. There's no fault protection. You can be electrocuted, before these fuse blow up or anything trigger here. So this is why. It's a best practice, not best practice, it's within the regulation as well. We should keep them within the um, uh, 2 meter or 3 meter length. If it is more than 3 meter, we're probably going to have something in between there to protect these meter tails, and or we're going to be replacing these meter tail with the armored cable or some within the conduit, metal conduit. So we have to look into it how we're going to protect these meter tail if they are but if we're going to be buried inside the building. So if they are uh, you know service mounted within the trunking, so okay, that might be something is acceptable. But no, if there's going to be buried inside the wall, now we should definitely have some sort of protection for these meter tails as well. Okay. Okay, let's talk about man protective bonding. So this is man protective bonding. You will find this cable. This is a 10 mil cable. They protect. So they connect to your water supply and gas meter both. So because they are these parts they're grounded. They are metal. They are metal lead. So because they need to be linked to your um, sorry they need to be bonded. So this is where if there's a problem, you gotta some you've got potential in your property, so they need to be linked as well. Okay. Sometimes you do find these man protective bonding. If this is um, disconnected or loose, damaged, you're probably going to be getting earthing from this side of they're going to be working as an earth rod, but don't be mistaken. Obviously, you still need to make sure this is the main distributor earthing arrangement. So they need to be um, obviously they should be firmly connected, and they should give you reading when you take the reading. Obviously, if it's a PME system, it should be more than 0.35. But if it's a TNS system, this earth is going to be connected to here, and obviously this is not combined. It's going to be a lead or something that's a separate to neutral. So this earth cable is going to be connected there. That's in those. If it's a TNS system, your ZD reading with the meter, if you're going to be taking reading, that should be more than 0.8, 0.8. Yeah. Okay. All right. As I said, this is going to be a 6 mil cable. Again, it's not, um, you know, it's not. We can't say this is the rule. We need to have a 6 mil cable. We can't have 10 mil cable here. We can't have a 4 mil cable. It depends on, as I said, it's a design current. We need to make sure whatever we're going to have there, it should be able to handle the appliance current, and at the same time these are CPUs there to protect your cable with additional protection, fault protection. So if there is overloading, that needs to trigger um, as well. So before your cables start deteriorating or catch fire. So this is where you need to do the design current. Okay, so yeah, I'll just put on a 6 mil. So it could be, as I said, it could be any size. All right, so this is 2.5 mil cable. This is what you normally find in the socket. Sometimes you do find a 4 mil cable as well, but yeah, 2.5 is normally you will find. So then again, you need to look into the length of the cable installation method. All these things need to consider. As you can find there, it's 20 amp fuse or sorry, 20 amp RCB or 16 amp RCB. This is 1 mil twin and earth cable. That's another lighting circuit. So obviously the lighting circuit, as I previously mentioned, you will have a 6 amp breaker. Again, length, design, all these things need to be considered. And if you got a you know these days people don't used to tend to have a down lights, all sort of lights. If they're more than um, you know if you think their lighting is need to be segregated because of the overloading or any other reason, as I previously mentioned, it could be as you don't want your lighting to go off in the night. If this RCP trigger, you don't want your upstairs, downstairs, and outdoor all lights to go off. So if it's segregated, so you're probably going to find 2, 3 RCBs, yeah, feeding to your lighting circuits. Okay. All right, so I've just put down 32 amp RCPS. If it's a 6 mil cable, so you might find a 32 amp RCPS there. Again, that's not something I would say it always going to be a 32 amp. Now it depends. It's a design crunch. You have to calculate and make sure you got appropriate sites RCPS there. So this is, as I said, 20 amp. It could be 16 amp. It depends. Um, yeah, a design crunch and your calculation, ambient temperature, grouping factor. These are all factors you need to take into account. And voltage, again, if it's voltage drop, that's something you need to consider as well. So yeah, that could be 16 as well. This is a 6 amp. You normally find a 6 amp RCBOs. So yeah, then again, you need to work on the design current. Okay. All right. Concentric cable. I think I already discussed concentric cable. So, and discuss about double pole isolator as well. So to connect this consumer unit, you're going to be isolating this double pole isolator if it is there. If not there, you're probably going to call the suppliers because these meter tails will be connected to your man switch, and you will ask them to install a double pole isolator or disconnect this isolator. You can install a double pole isolator, or you can connect these meter tail direct to your consumer unit. Yeah, sometimes sometimes people don't want to have these double pole isolators installed if they got a box right outside of their door, your property. So obviously, if somebody wants to um, it could be a security reason, so I don't want to get into too much into details. That could be sometimes the bad people, if they can open your meter box and they can switch this old house electricity off. Its electric's gone, your internet's probably going to go off at the same time, and they would love it, and they can get into your property and cause maximum damage because your CCTV system is not working, your electric is off, so if you're not home, you're probably not going to be able to know. But yeah, if you do have a box outside there, if you got these isolated, don't just rely on a um, normal lock, you normally find with the gas meter and electric meter. You can have additional lock there or security lock there, which is going to be linked to your alarm if somebody tried to interfere or open your meter box, and your alarm system that should trigger. um, yeah, this is something you need to look into. Okay, yeah, but they're very handy in terms of if you want to install and upgrade your consumer units. Obviously, that could be something you can isolate your supply there and upgrade and work there on this side. Whatever needs to be done. Yeah. Okay. Yeah. Sometimes we don't have this double pole isolator. We will find this handy block there, which is still okay. And I mean, we can see here, this is labeled the top terminal. If you open there, there can be a terminal, neutral terminal on top there with these neutral cables connected, and the bottom part is a line conductor. There's meter tails. Yeah, line conductor meter tail is going to be connected at the bottom. Okay, just to make sure whenever you need to work on this, you have to make sure because this is exposed. So um, I don't know how you're going to work on this one. Ideal, this fuse that needs to be disconnected before you link to this one. But if it is, sometime we do have to work on a live electric as well. But if you are, it's not about confidence, it's about the safety. So if you have to work on this one, you have to be very careful to work on this handy block. So you need to make sure these two connected first. You don't want to be if the meter tail is coming from your meter, they need to be connected. Then you can link your board. If you by mistake, if this is alive and you can try to connect the neutral of this neutral on the same side that you got mixed up, then you could cause the damage to yourself or the system, this electrical system. Okay, yeah, which is okay. But one thing I will say, there should be sealed here. This need to make sure is firmly, this top cover is firmly tightened, it's not loose, and that needs to be sealed. If I was be working on this one, I put another seal that could be something laminated type, the glue type, in case case if this part get damaged and this is loose, and there's going to be a second layer of the security, so which is going to be sealed this side as well. So okay, yeah. All right, this is again, this is a handle block. We do find some of the property these as well. So I forgot to mention, these cutout, they do have these terminal there, so you gotta make sure when you're working there, so you need to, whenever you're doing electrical installation condition report as an electrician, make sure they're not exposed. There might be the knockouts that are missing there, so that's exposed. They need to be covered. And similarly here, if these cables coming to this terminal this side, so these two, they need to be closed, they shouldn't be exposed. So that doesn't mean, you're gonna poke your finger in there, your finger won't be able to get in there. So that could be something, Tom, you're holding a wire or something, the metal part, spoon, anything. So I wouldn't say you're gonna be working with the spoon here, but it could be any tool, so that could get into there. And if you're holding on your hand, in the left side of, yes, there could be a catastrophic. Yeah, they need to be sealed. They should be sealed. I can see here this is a brown cable to give you indication this is a line, and this is a blue cable that again give you indication this is a neutral. And this, well, we can't find the tape here, but we do find somebody did write down with the pen, and to indicate neutral and sign with the light. Seems okay as long as you can see these not open, but all my main worry is here. I don't know whether the electrician didn't have a 25 cable meter tail, so that's where he used the one leg here, which is a neutral, is a 25, and this looked like a 16 mil cable. So if that's the case, I think that need to be replaced with the same size as the neutral. They can't be different. I wouldn't be happy to give a satisfactory certificate if they are the different size. Okay. All right, this is again, that's a good one, isn't it? Here we, um, the electrician, they probably didn't have a 25 mil cable, so they used the old cable. One of them is a 16 mil, and one is 25 mil. Here, I think they ran out of the tape. Okay, this is not acceptable. These insulation, if there is insulation removed, that should be inside the enclosure. It says outside the enclosure, but this is there. Insulation, this double insulation, it is to protect your cable. If somebody is removing this insulation just to give the indication which one is a line and a neutral, I think this is lazy. They need to put a proper label there, or the tape, whatever, to indicate. Even if they could have written down, that still would have been acceptable. This is not, if I was there, I would definitely give C2. C2 is again, if you get electrical installation condition report certificate, you will find C1 and C2. C1 is imminent danger. That could be a basic protection failure. So, as I said, if there's any exposed part which is accessible, um, you know, unintentionally accessible, that could be something classed as a C1. And if there's insulation failure here or fault protection missing, that's classed as C2. And in both cases, you won't get a satisfactory electrical installation condition report till remedial works is carried out, and yeah, to meet the satisfactory level of your electrical installation. Okay, yeah, that's not acceptable. So this is a good, they do have a um, double pole isolator, but it seems it's not. I don't think it's National Grid or someone done. I think it must have been a DIY person who, I don't know how they managed to get these cables there. I think it looked like the main incoming supply. That could be outgoing, but it looked like a main incoming supply from this side. But yeah, that should have been fully insulated. Okay, yeah. Okay, this is another one. That's a good one. Yeah, we know these meter tails again. This is, as I was discussed previously. This is knockout. This is capped, that's good. So obviously you can't get access to the live board. And these meter tails going to the meter and then feeding to this switch isolator there. Okay, that seems alright. Is this a label this side? That should be labeled this side as well to indicate which one is a line and which one is a neutral. But that's missing then again. I can't clearly see here, but these holes, they need to be, there should be some sort of protection there as well to meet acceptable IP rating for these the top surface of this isolator. So these meter tails, again, they're no label. I can't see any label there. But then again, you need to make sure because they are double insulated meter tail, and I believe this is installed there where the cable length is probably more than 2 meter. So that might be this is probably going to be depend how big size, what size this man fuse is inside this enclosure. So this probably then reduce it to the 80 amp, and if it's more than 3 meter cable, then again it needs to be investigated. Where these meter tail going to with the consumer unit, it could be 15 meter, 10 meter from this fuse. If that's the case, these meter tails they need to be protected. There should be some sort of protection, and if not, they need to have RCD protection there to protect these meter tail if they are buried inside the wall and the ceiling, and there isn't any protections applied. If it would have been a different cable, armored cable, still you can um, damage can be caused to the armor cable again. But yeah, there should be some sort of protection there if this meter tails is gonna be feeding to consumer unit, where the consumer unit is probably 10 or 15 minute, 10 or 15 meter from this switch fuse. Yeah, okay, that's it for today. So we'll discuss later on the next. Sorry, apologies. Due to some reason, these man protected bonding cable and distributor earthing arrangement, they still show in black color. They should be in obviously green and yellow color, but unfortunately due to some reason there could be some sort of technical fault with this presentation. They are still coming up with the black color, but yeah, they are not black, they are yellow and green two color cable. Okay, thank you very much.